part A. We want to use our algebra skills to solve for this. So sometimes what you have to do is sort of imagine yourself going back to grade 10 or going back to grade 11 and start this question off like that. Well, how would I solve this equation with 7 plus 2 sine x equals 4 sine x plus 5? Well, I would put my like terms together. So I'm going to subtract 5 on both sides. 7 minus 5 is 2. I'm going to subtract 2 sine x on both sides. And I'll get 2 sine x equals 2. Dividing by 2 gets sine x by itself, and we get sine x equals 1. So that first part, just getting sine x by itself, is just like we've done previously. Now this question would be a non-calculator one if it came up on your final exam. So that means when we got sine x by itself, we should be able to do this without our calculator. Is the value of 1 on your unit circle, on your pie plate? What angles for sine, remember sine is your y-coordinate, what angles do you get? Just 90 degrees, okay? And notice that if I started this way and wrote 90 degrees, and that's one of the things that we're sort of going to use as a strategy, we're going to first solve like normal between 0 and 360 or 0 and 2 pi. Then after we've solved between 0 and 360 or 0 and 2 pi, you have to check what is the domain given in the question. The domain given in the question said find all of the answers between negative 360 and 0. So that's like imagining your pie plate but going in the negative direction rather than in the positive direction. So if I was going in the negative direction, what would be, so this one is outside of my domain, but what would be my angle that's coterminal, ends in the same place as 90 degrees, but in the negative direction? Negative 270 degrees. So now that we've solved it between 0 and 2 pi, this question also said, also write the general solution. If we remember from our notes yesterday or the day before, the general solution, you first solve it between 0 and 360 degrees or 0 and 2 pi, which we did and got 90 degrees. And then for each of your answers between 0 and 360 or 0 and 2 pi, you'd add plus 2k pi if it was in radians, but because this one's in degrees, our general solution is going to be, we only have the one answer, which was 90 degrees, plus, instead of 2k pi, we'll do 360 degrees times k, where k is an integer. So the general solution, again, you solve it between 0 and 2 pi or 0 and 360, depending if your question's in radians or degrees, and then add 2k pi or 360 degrees times k, again, depending if it's in radians or degrees. So in part B, we have cos 3x equals negative 1. It first says to solve it between negative 2 pi and 0, and then it says solve it, determine the general solution as well. So it's going to want the general solution and the solution between negative 2 pi and 0. Now, whether we're solving it as a general solution or the solution of negative 2 pi to 0, we are first always going to sort of solve our questions in the first time around. So from 0 to 2 pi. Notice this is a multi-revolution question. These are the ones you were working on yesterday. Okay? So if we were first going to solve this between 0 and 2 pi, if 1x were between 0 and 2 pi, then 3x's would be between 0 and 6 pi. So what we do with the multi-revolution question is, instead of, normally we just have an x inside of the cos, or just a theta inside of the cos, and then we write x equals. Well, now we have a 3x inside of the cos, so we're going to write 3x equals. But when solving for 3x, we have to go 3 times around the circle. Because x is once around the circle, that means 3x's would be 3 times around the circle. Is negative 1 on our pi plate for cos? When does that happen? At 180, but this is now we're thinking in radians. So it would happen at pi, but that would be the first time around. What about the second time around? 3 pi the second time around, and the third time around? At 5 pi. So a multi-revolution question means you're going to solve it, in this case, 3 times around your circle. Then to find out what x would be, we divide each of these by 3. So now we've solved our answers from 0 to 2 pi. These answers are here, are all of our answers from 0 to 2 pi. The question didn't ask for 0 to 2 pi. It asked for negative 2 pi to 0, and it asked for the general solution. So underneath here right now, I'm going to split this up. We'll do the general solution over here. And we'll do from negative 2 pi to 0 over here. So if we're going from negative 2 pi to 0, that's once around in the negative direction. Can you tell me what is coterminal with pi over 3? So one way that I like to think about this is I take out my pi plate. I find out where pi over 3 is, right there. Okay? That's in quadrant 1. If I was going in the negative direction, if I was counting quadrants in the negative direction, it's like going 1, 2, 3. It's like going 4 quadrants in the negative direction. Something in quadrant 1 in the positive direction means you'd be going into 4 quadrants in the negative direction. And I like to think that way because then I can say to myself, well, what is the pi over 3 family member in quadrant 4? Five pi over 3. So if I was going in the negative direction, then the angle coterminal with pi over 3 is going to be negative 5 pi over 3. What about pi? If I was going in the negative direction, what would be coterminal with pi? Negative pi. And if you're going to 5 pi over 3, which is in quadrant 4 in the positive direction, well, that's going to be the pi over 3 member just 1 quadrant in the negative direction. So it's going to be negative pi over 3. So there's our solution between negative 2 pi and 0. If we wanted the general solution, again, the general solution says solve between 0 and 2 pi. We did that already. Then take each of your answers, write them out, pi over 3, pi, and 5 pi over 3, and add 2k pi to each of them. So again, those were review questions that we've done a bunch of these already. 4, 8, and 9 are questions you can do for practice.